Hello, myself Ramesh, working as assistant professor in Laxman Reddy Institute of Technology and Management. So in today's session, we are going to discuss about helium neon laser system. So before going to discuss about helium neon laser system, so let us discuss about some brief introduction about laser. So first of all, we should know what is mean by laser. So laser stands for light amplification by stimulated emission of radiation. So means light will get amplified by the process called stimulated emission and finally radiation comes out. So like this we can elaborate the term laser here. So next to this here, what is mean by laser first of all? So what is the importance of laser and what is the difference between normal conventional light to laser light? In the sense, here we can describe the laser like laser is a device that amplifies or increases the intensity of light producing high directional light. So normally if you observe, if you switch on normal light and laser light, the directionality different you can observe. So normal light can uh, split in all directions, but laser light cannot deviate in all directions here. So laser light's directionality is more. So laser light can travel in single direction. So like that, the directionality will be high for laser we can say. And also the intensity point of view also. So lasers are highly intense in nature comparing to other light sources here. That is also one of the advantage of laser we can say. So lasers not only amplifies or increases the intensity of light but also generates the light. Okay, so it also like a light and radiation. So here like this we can describe some points about laser here. So now coming to our concept helium neon laser. So what is helium neon laser in the sense? It is a gas laser system. So gas laser system in the sense, in this laser system, the active medium we are using is gas material. Okay, helium gas and neon gas we are considering as active medium in this laser system here. So that is the reason it can be called as gas laser system. So let us see. So this gas laser system developed by Ali Jawan and his team. So these people are developed this first gas laser system in the year of 1961 in their laboratories. In Bell Telephone Laboratories, they developed this laser system here. It's useful to operate the wavelength of 6328 angstroms. Okay, the laser output of helium neon laser system is around 6328 angstroms in red color. So red color wavelength you can get by this laser system here. And also this laser system works in 4-level process. Okay, 4-level laser system it is. So which means it can emit the laser light in continuous process. Okay, 4-level laser systems are example for continuous laser systems here. So, and let's see few more points about this laser system. Here, this is the diagram representing the construction of helium neon laser system here. So, as shown here, this laser system consisting of a discharge tube setup. So, here this is the discharge tube setup here. So, in this discharge tube, we are taking the gases of helium and neon. Okay, the active medium helium and neon gases mixture with ratio of 10 is to 1%. Means 10% of helium gas and 1% of neon gas we are taking in this discharge tube. Okay, and that is the active medium. And next, the second important process we need to discuss is about pumping. So what is the pumping method we are using in this laser system in the sense? We are using electric discharge. So electric discharge method we are using as a pumping method in this helium neon laser system. So we are applying electric discharge to this discharge tube via this anode and cathode. Here we are having both sides anode and cathode set up to this discharge tube. So to these two anode and cathodes we are providing electric discharge. Whenever we are providing electric discharge, automatically by that electric discharge the helium and neon atoms whatever presented in the discharge tube, they will get excited from lower energy levels to higher energy levels, and between their energy levels some atomic transitions will take place, and as a result we can observe laser photons. And next, another important criteria in this laser system is, so two mirrors we are placing at both sides of this helium neon laser system. So those two mirrors are here, these two. So two mirrors, one is highly reflective and another one is partially reflective mirrors we are arranging. So highly reflective in the sense, so that mirror was completely coated with silver. Okay, so the photons cannot escape from that mirror. So that is one side, and another side we are arranging partially coated mirror, around 90% coated mirror we are placing other side. So because it is partially coated, the photons can get escape from this partially coated mirror here. So by that we can achieve the laser output from this partially coated mirror. So that's why here arrow mark was indicated this side. So means laser coming out from this partially coated mirror as a output from this helium neon laser system here. Okay, so this is the construction of helium neon laser system we can draw. So let's discuss about individual parts of helium neon laser system here. So here construction once again we are discussing. So in this helium neon laser system, as I told you, we are using helium and neon gases as active medium with ratio of 10:1. Means 10% of helium and 1% of neon gases we are taking as active medium here. Okay, and next, the setup consisting of long and narrow discharge tube of length 80 centimeter, diameter of 1 centimeter. Okay, the discharge tube size what we are using in the construction is, the length is 80 centimeter and the diameter is 1 centimeter. So that is the size of discharge tube we are using in this helium neon laser system here. Next, the pressure, how much pressure we are maintaining inside in the sense 1 millimeter of Hg. Okay, so this much of pressure we are maintaining in the working of helium neon laser system here. So next to this, the electric discharge. So as I told you, the pumping method we are using in helium neon laser is electric discharge method. So under this electric discharge, we are providing 1000 volts power supply to this helium discharge tube. Okay, the energy or pump source of laser is provided by electric discharge of around 1000 volts through an anode and cathode at each ends of the glass tube. So to the discharge tube we are providing 1000 volts of discharge here. So next, the optical cavity of laser typically consisting of plain higher reflective mirror at one end and other end partially transmitting mirror. So as I told you, so to the both sides of discharge tube we are placing one fully coated mirror and one partially coated mirror. So two mirrors we are arranging. So that arrangement we can call as optical cavity. So optical cavity or resonator setup you can call it as. So these are some important points of construction. So by that the process is taking place in helium neon laser. So whenever you are providing electric discharge to the discharge tube, so the discharge tube consisting of helium and neon gases with a 10:1 ratio. So by absorbing that voltage, so first helium, majority of helium atoms are presented, 10% of helium presented, that's why first helium atoms absorbs that energy and excites from lower energy levels to higher energy levels here. Here you can see on the screen the energy level diagram of helium neon laser here. So first of all we are having helium atoms and neon atoms. So these energy levels belongs to helium atoms and these energy levels belongs to neon atoms here. Okay, whenever we are providing electric discharge, first helium atoms are exciting from ground state, nothing but F1 to higher energy levels F2 and F3. Okay, they are absorbing the electric discharge energy and exciting from lower energy level F1 to F2, F3 here. So because of helium atoms are majority, so majority of helium atoms are exciting from lower levels to higher levels here. So after get excited, so these helium atoms are making collisions with neon atoms here. Okay, the excited helium atoms makes resonant collisions with neon atoms which are in ground state. So then because of resonant collisions, the helium atoms energy will be transferred to neon atoms. Then by taking that energy, neon atoms also exciting from lower energy levels to higher energy level here. From E1 to E6 they will get excited. Okay, so that is the process taking place. Here in this helium neon laser system, helium atoms are not directly involving in the laser transition. So helium gas we are using to provide excitation to neon particles here. Okay, for excitation purpose we are using helium gas here. So now the excited helium atoms exciting from lower level E1 to higher energy level E6 here. So here E6 is the metastable state. So metastable state here. So what is mean by metastable state in the sense? So metastable state is a energy level which is having long lifetime. So comparing to higher energy levels, the metastable states are having long lifetime. That's why the atoms can stay for some extra time in the metastable state. So then population inversion achieves at metastable state here. So population inversion is nothing but, so the number of atoms will be high in higher level comparing to lower level. So like that, the population increases in higher energy state E6 comparing to E5 level here. So by that, the atoms which are excited to higher level, they slowly comes down and gathers in E6 energy level here. Okay, so the population inversion achieves in E6 energy level. So after achieving population inversion, the atoms which are stayed in E6 level, so they slowly comes to ground states. Okay, from E6 the transition takes place to E6 to E5 and E6 to E3. So these two transitions will takes place. So in E6 to E5 transition, so we can get 3.39 micrometer laser intensity, and in E6 to E3 transition we can achieve 6328 angstroms of laser intensity here. Okay, so means high laser intensity we can achieve in between E6 to E3 transition. Okay, the remaining transitions are also happening, but ultimately the high wavelength we can achieve in between E6 E3 transition here. And also another transition also taking place, that is E4 to E3 transition. In E4 to E3 transition we are achieving the laser intensity of 1.15 micrometer. So here majorly we are achieving these three transitions here. So E4 to E3 transition, here you can achieve 1.15 micrometer. So like this, these three important transitions we can observe. From these three, the higher intensity we can achieve in E6, E3 transition, that is nothing but 6328 angstrom here. So the laser output of helium neon laser, we can say that as 6328 angstrom, that is happening in between E6, E3 here. So like that, the atoms slowly comes down to lower energy levels, E6 to E3, E5 and E4 to E3, and next from E3 slowly they comes to E2 level by spontaneous emission. So spontaneous emission in the sense, so themselves they comes to ground level. Okay, without any external force, themselves they come to ground level before after lifetime. So in this transition they emits 0.6 micrometer laser intensity, very less, negligible one. So after E2, then they slowly drops to ground level E1. So de-excitation by collision to discharge tube walls. Okay, slowly they drops to ground state here. So like this, the atoms transitions takes place from lower energy levels to higher energy levels in helium neon laser system here. So this is helium neon laser system energy level diagram we can say. So what is the need of taking helium and neon gases here? In the sense, as I told you, helium gas not directly involving in the laser action. So neon gas particles only active laser particles here. So because of transitions between neon gas energy levels only we can achieve laser intensity here. Okay, and what is the reason for choosing helium and neon gases particularly in this laser system? In the sense, because the higher energy levels, the energy levels are approximately same for helium and neon gases. Okay, the higher energy levels are approximately same. That's why the energy transfer can easily happens between helium atom to neon atoms. Okay, excited helium atoms makes collision with neon atoms, and then neon atoms also excites from lower energy levels to higher energy levels here. So this energy transfer can happens easily because both energy levels are at same levels. Okay, that is the reason only we are choosing these two gases as active medium in helium neon laser system here. So next, here this is some small explanation about our energy level diagram. So what we saw previously. So electric discharge is passed through the gas, and electrons have small mass than ions, then acquire higher velocity. So nothing but by providing electric discharge, the helium ions will excite to higher energy states. Helium ions are more radiatively excitable than neon. So they are highly concentration. Okay, so comparing to neon, helium atoms are morely excitable because the population of helium also high. That's why helium atoms first excites from lower energy levels to higher energy levels here. The role of helium atom is to assist pumping neon atoms to higher energy levels via interatomic collisions, as I told you. Okay, helium atoms not directly involved in lasing action. So helium atoms role is to provide excitation to neon atoms here. Next, so electrons collisions with helium atoms excited them to metastable states F2, F3. Okay, so as I told you, so from F1 to the atoms excites to F2, F3 states first. Because of electric discharge, helium atoms excites from F1 to F2, F3. Next, here you can see. So after helium atoms are excited, so the helium atoms loses energy through collisions with unexcited neon atoms. So as I told you, the excited helium atoms makes collisions with ground state neon atoms. Resonant collisions will take place between helium and neon here. So then neon atoms also excites from lower energy levels to higher energy levels here. So which have nearly the same energy as the levels of F2, F3 of helium. So the energy levels are approximately same for helium and neon, as I told. Next, the probability of energy transfer from helium atoms to neon atoms is more, as there are 10 helium atoms to 1 neon atom in the medium. Okay, so 10 for every 10 helium atoms, 1 neon atom was presented. That's why the collision can happen easily. So the population inversion is achieved between E6, E3, E6, E3, E6, E5 and E4, E3. As I told you, the three major transitions takes place. So this is E6 to E3 and E6 to E5 and E3 to E4 to E3. So these three transitions takes place by achieving population inversion here. Here population inversion achieves because E6 is the metastable state here. Okay. So next, E6 E3 transition generates the laser beam of red color of wavelength 6328 angstrom. From these three transitions, the major important transition is this 6328 angstroms wavelength emitting in the transition of E6 to E3. Okay, so the laser output also in red color we can achieve in this transition. Next, E4 E3 transition also emits 1.15 micrometer laser intensity, okay, which is not visible. Okay, so that intensity we cannot see because it is in infrared region light. It is invisible radiation. Okay, E4 to E3 this E4 to E3 transition. Next, E6 E5 transition emits 3.39 intensity and E3 E2 transition generates incoherent light due to spontaneous emission. So E6 to E3. So here in this transition, because of spontaneous emission, we can emit 0.6 micrometer laser intensity here. Okay, next. From level E2, the neon atoms brought back to the ground state through collisions with walls. Okay, so while the atoms are slowly coming to ground state, they make collisions with the discharge tube walls and they falls to ground state here. From E2 to they falls to ground state. Also, E2 level is a metastable state. It can decrease the population inversion by exciting atoms from E2 to E3. Hence, the tube is made narrow so that neon atoms in E2 de-excited by collisions with walls of the tube. So the wall tubes, the discharge tube size is very small. That's why. So instead of exciting to higher level again, so that drops to ground state here. Next, by proper design of resonator, laser action in neon is obtained in visible region of 6328 angstrom. Okay, so in the visible region, we can achieve the laser intensity of 6328 angstrom in helium neon laser system here. So next, here we are going to discuss about some applications of helium neon laser system here. So here where we can use helium neon laser system in real life in the sense. So narrow red beam of helium neon laser system is used in supermarket barcode reader. So if we go to supermarket, so there at bill counter, they are scanning the goods what we purchase. Okay, for the goods they are attaching some barcode system. So if they scan that barcode system on the screen, it displays the product name and its price. Okay, so like that. So to read the barcode system, we can use helium neon laser system here. So nowadays in supermarkets, in shopping malls, wherever we go, you can see these helium neon laser systems at bill counter. So that is one of the important application of helium neon laser system. And helium neon laser system is used in holography in production of 3D image of objects. Okay, so 3D image capturing. So the technology we can call as holography. So generally photography is a 2D picture capturing. So in holography, to capture three-dimensional picture, so in that holography technology, we are using laser lights. So as a laser source, we can use helium neon laser in holography technology here. So next, helium neon laser have many individual and scientific uses and are often used in laboratory demonstration of optics. Okay, in our regular labs. Okay, in colleges, in other normal domestic labs. So we can use helium neon laser system as a laser source. So to exhibit some optical phenomena like diffraction and other optical phenomena, we can explain with the help of this helium neon laser source. Okay, so like in optical fiber communication system, how the signals can travel in optical fibers, and also in this optics related experiments also we can execute with the help of this helium neon laser source, because their intensity is less comparing to other laser sources. That's why in our normal labs also we can use helium neon laser as a laser source here. Next, here are some advantages we are going to discuss. Okay, following are the advantages of helium neon laser. So what are the major advantages comparing to other laser sources? In the sense, helium neon lasers has very small length, approximately 10 to 100 centimeter. Okay, the laser tube size is very small. So that around 10 to 100 centimeter, very small in size. So that is one of the advantage. That's why we can use it in in our regular life applications also. Next, cost of helium neon laser is very less comparing to other lasers. Okay, other laser sources are very costly, but helium neon laser source is very cheap in cost. So that's why we can use in our regular equipment. So like our optics related experiments, in other experiments we can use helium neon laser sources. As I told you, in supermarkets also, for barcode reading purpose also, we can use helium neon laser as a light source. Next, construction of helium neon laser is not that much complex. Okay, so very easily constructed laser system here. So not that much complex construction it is having. Okay, so a simple construction laser system it is. Next, helium neon laser provides inherent safety due low power output. Okay, the intensity or power output is less. That's why it is not that much harmful to our human bodies also. Okay, that's why we can use in our regular barcoding system, or in labs also we can use this laser system, because less power laser it is. So next, coming to the drawbacks. So what are the drawbacks of helium neon laser? So here you can see some drawbacks also. Helium neon laser is low gain system and device. Okay, as I told you, less power, and also the gain also very less. Next, high voltage required. So as I told you, For electric discharge, we are applying 1000 volts to the discharge tube as electric discharge. So that's why the voltage we are providing to function helium neon laser is very high voltage we are applying. That is also one of the drawback we can say. Next, escaping of gas from laser plasma tube. So because gas can leak easily from the discharge tube, okay, the gases can easily escape from the discharge tube. Some leakage problems are also presented in this helium neon laser construction. So that is also one of the disadvantage we can say. So these are some advantages and disadvantages of helium neon laser system we can say here. So here these are the references I was taken to explain this topic. So thank you for listening.